All right, let's get right into it. When it comes to GCSE chemistry, one of the absolute best ways to learn is to break down real exam questions. So today, that's exactly what we're going to do. We're taking a close look at question 9 from an AQA paper, and I'll walk you through how to nail every single mark by thinking just like the official mark scheme.
So here's our game plan. We'll start by getting our heads around the experiment itself. Then we'll spot a pretty big error in the setup. After that, we'll dive into the results graph and figure out what it's telling us. We'll tackle a beast of a 5-mark calculation, pick out the right catalyst from a lineup, and then we'll wrap it all up with a checklist of all the crucial skills you've just sharpened. Sound good? Let's go.
Okay, so first things first, let's set the scene. This whole question is built around an experiment, looking at the rate of reaction between some zinc powder and sulfuric acid. And here it is. This is literally what students were looking at in the exam. You've got the chemical equation, the step-by-step method, and a diagram of the whole setup. It's a really classic experiment for measuring how fast a reaction is going by seeing how much gas it produces. But pay close attention to that apparatus diagram. There's something not quite right. This brings us to the first part of the question, 09.1. This is a classic exam skill they love to test. Can you spot what's wrong with the picture? It's just 1 mark, but it really shows if you understand how these experiments work in practice. So have a good look. The whole point is to get the hydrogen gas that's produced in the flask to travel down the tube and into the gas syringe so we can measure it. So what's the one critical mistake here that would stop that from ever happening? And there it is, straight from the mark scheme. The delivery tube is actually under the surface of the acid. I mean, think about it. If the tube is in the liquid, how is the gas supposed to get into it? It can't. It would just build up pressure, probably push the acid back up the tube, and the experiment would be a total failure.
Okay, so errors spotted and fixed. Let's imagine the student has now done the experiment correctly and collected some data. Now comes the next part. We've got to interpret this graph to answer the next couple of questions.
Here's our graph. It shows the volume of gas made over time using 2 different concentrations of acid. Now, the question wants to know why both of these lines eventually go flat. What does a horizontal line actually mean on a reaction rate graph? Right, a flat line just means the reaction is over, it's stopped. That's your first mark. But you need to explain why it stopped to get the second mark, and the reason is simply that one of the reactants, either the zinc or the acid, has been completely used up. There's nothing left to react. The mark scheme also shows you can get away with saying something simple like no more gas produced.
Okay, on to 093. This one's all about comparing the 2 lines. The question is asking for the evidence from the graph that shows the reaction with the weaker acid, that's the solid line, is the slower one. What's the giveaway?
And here you've got 3 perfectly good answers, and you only need to give 1. The most obvious one is that the line is simply less steep. Just remember this rule. On a rate graph, steeper means faster. So less steep means slower. Simple as that. You could also say that in the same amount of time, it produces less gas. Or you could point out that the whole reaction just takes longer to finish. Any of those will get you the mark.
Okay, deep breath. Here comes the main event, the 5-mark calculation. I know these can look really intimidating on the page, but I promise you, they're just a process. If you can remember the steps, you can get all 5 of these marks.
So the task is very, very specific. We need to find the rate of reaction for the solid line at exactly 80 seconds. Now, the problem is that the line is a curve. We can't just find the gradient of the whole thing. We need to find the instantaneous rate, the speed of the reaction at that single moment in time. And here is the 5-step playbook, straight from the people who will be marking your paper. First, you draw a tangent to the solid curve right at the 80-second point. A tangent is just a straight line that perfectly kisses the curve at that one spot. Next, you use that tangent to draw a big right-angled triangle and figure out the change in the y-axis and the change in the x-axis. Then you calculate the rate. It's just the change in y divided by the change in x. And finally, and this is so important, don't forget this, you have to give your final answer to 2 significant figures to get that last mark. So on your exam paper, you'd literally take your ruler out, carefully draw a straight line that just glances off the curve at 80 seconds, pick 2 points on that line that are easy to read, and then calculate the rise over run, making sure to round your answer at the end. We're on the home stretch now. Let's move to the final piece of question 9. This one is a multiple choice question, and it's a test of your chemistry knowledge about catalysts. The question says adding certain metal ions lowers the activation energy. Now, as soon as you hear lowers the activation energy, you should be thinking catalyst. So of the four options here, aluminum, calcium, copper, and sodium ions, which one is a famous catalyst? The correct answer is copper 2+, copper 2 ions. This is one of those key facts that's just really useful to remember. Transition metals like copper and their ions are often fantastic catalysts for all sorts of reactions.
And just like that, we've made it all the way through the question. So before we finish, let's just step back and look at all the different skills we've had to use. This is the real gold from an exercise like this.
Just look at that list. In one question, we've covered practical skills by spotting the error, we've analyzed a graph, we've compared rates, we've had to accurately draw a tangent and do a big calculation, and we've even had to recall a specific fact about catalysts, and all the while paying attention to details like significant figures. Mastering this mix of skills is exactly what you need to do to ace your chemistry exams. Honestly, this process, breaking down a real exam question and checking it against the mark scheme, is one of the most powerful revision techniques out there. It doesn't just test what you know, it teaches you how to give the examiners exactly what they're looking for. So, what should we break down next? Let us know.